The focus of this video is on inverse standard normal distribution. So I kind of want to focus you on this Desmos graph to kind of orient ourselves to where we were. So we went from calculating the area that is represented by the shaded region here under this curve, right, by plugging in z values or negative infinity to a certain value. So we started there, and now we're going to be doing the opposite. So now we're going to be given the area, and we have to find the z-score or the data point that was involved in the problem. So we're kind of going backwards. And the first thing I should mention is that this graph no longer is going to work. There's no way in any of these places for us to put the area. We can't change it here. We can't change the probability. So this brings about a new Desmos calculator. So on Unified Classroom, there is a new link to a new Desmos calculator like this one. It's a blue graph. And this is where we will be able to change the area. You can see it right here where it says A equals. We're going to be able to change that area to find new z-scores. But before we get into that, let's look at the different types of things that you're going to see. So inverse standard distribution kind of works where there's three different cases or three different situations with percentages that you're given. So the first one is where you're given just a flat percentage or area or percentile. Remember, they have multiple names. So that's this first section right here. So what you can see in this example is that it was asked to calculate the z-score of an area of 35%. Okay, so when you're in Desmos, what you'll do is you'll go to where it says A equals, and you'll type in this case, I typed in 0.35 because I needed to change 35% into a decimal, so I divided it by 100, giving me that 0.35. Once you do that, your area should set up here, and the thing that you're interested in is this number down here. This number is your z-score. And that's kind of the key to it all. Sometimes that's all you need to give is the z-score, and sometimes you need to go a step farther. So we'll kind of move into that as we continue. But this is the first section, or first type of question. Again, you're given just a flat percentile or a flat percentage, and you just plug in that as a decimal and pull out the z-score. The second situation that you could be given is when you're given the top or highest percentile. So in this case, this example says the z-score that corresponds to the top 15%. You have two choices. This is choice number 1, and this is choice number 2 in terms of how to do this. Your first choice is to go ahead and type in the area is 15%, right? Because remember, 15 divided by 100 is 0.15. That's your first choice, to type that in. But you need to recognize that this shading right here is not in the top 15%. But if you remember, a bell curve is something that's set up symmetrically. So essentially, if this is the bottom 15%, then if I go over here to this section right here, this is going to be its positive counterpart that represents the top 15%. So if you do option 1 and you type in the percentage as is, you just need to find its opposite z-score. Because that would represent the top. Okay, so this is option 1. Option 2 is to actually take 100% minus the 15, get 85%, and then take that as a decimal and plug it in. That would give you, yes, it's going to highlight the lower half, but really it still gives you that z-score that you're interested in. So when it asks for the top or highest percentile, you either have choice 1, type in the percent, use the opposite, or choice 2, type in the opposite, and then you're taking that exact z-score that you see. All right, option number 3, and this I think is, for the most part, the most confusing, is the middle, when it asks for the middle percentage. So just to kind of clarify here, so when you think about a normal distribution curve, this being 0, when we say the middle, we mean that we're going to go 10%, or I'm sorry, not 10%, 5% to the left and 5% to the right, which I think my example, I did this differently. So let's change this to the middle 20. I apologize. Okay, so in the middle 20. So when we do this, 10% to the left and 10% to the right. And when you do that, you then can kind of see each of these z-scores. So what I did was I started at, because remember with area, this is 0%, this is 50%, and this is 100%. So when I think about that, if I'm dealing with percentages, if I need to go 10% to the left, I'm going to do 50 minus 10 and get, oh, I'm looking at this being 40%. This 40%, which is what I'm showing here, would be 10% away from the mean and would give me my z-score. You actually could stop here because remember, this is symmetrical. So if it's symmetrical, that means that if I do its positive counterpart, I'm going to get the other side of 10%, right? Which is down here as it's positive. These two things should be related in that way. Okay, so you have the negative and the positive. I did show it by going 10% above 50% and it's still working. Okay, so again, this in this example, you can do one, you could do both, but the range here would be these z-scores. Okay, so that's how you use the Desmos calculator to get the z-scores. But then, what if you're asked for the data point, right? What if you have to do something with it? Well, that's what's next here. So, and that z-score is still important. That doesn't go away. So let's say, for example, and you have to figure out this data point of this question. So we're dealing with kittens, right? And it says that there's a mean of 24.5 ounces and a standard deviation of 5 ounces. What's a kitten whose weight is in the bottom 10% is considered undernourished, right? What is the cutoff point for the weight of an undernourished kitten? So we're going to use this formula right here to kind of walk us through this. So we are looking for X. We want to know how many ounces is considered undernourished, this and below. So that's that X value. And we have the mean, that's 24.5. We have the standard deviation, that's 5, and now we have the z-score. You know, in the previous standards, we would find the z-score. We have it. We just have to, I guess, technically we have to find it, and it comes from this bottom 10%. So I would plug into Desmos 10% here. So, come on, keyboard. All right, so 10%. So now I can see from my graph that that's that negative 1.282. So I'm going to equal this here. So step 1, you still need to find the z-score, but then step 2, plug into the formula. So now we just have to solve. Remember, the best thing to do when you're solving this is to go ahead and get rid of the denominator first. So we're going to multiply by 5 on both sides. That cancels on the left. X minus 24.5 equals negative 6.41. And then we would add 24.5 to both sides, leaving us with X equals 18.09 ounces. So around 18 ounces or less is considered an undernourished kitten. That's kind of how this question works. All right, so let's go ahead and go into these next 3 questions. So I kind of pull it all together. I ask you each one of the percentage questions along with finding the data point that goes with it. So let's say it wants the 4th percentile. It doesn't say the top. It just says the 4th percentile. So the 4th percentile is going to be 4%. Remember, that's 0.04. And when I look, that's negative 1.751. So my z-score is negative 1.751. So now using my mean and my standard deviation, I've got X minus 550 over 75 equals negative 1.751. And then from there, I'm going to multiply by 75 on both sides, cancel. X minus 550 equals negative 131.325. And when I add 550 to both sides, I get X equals 418.675. The next question is asking about the top 8%. So remember, with the top, we have to do some different things here. I'm going to go ahead and type in 8% and then use the opposite. So I'm looking down here at my z-score. I can see that my z-score is going to be positive 1.405. Remember, I'm using positive because I wanted the top, even though I know it showed the bottom. So now I have X minus 550 over 75 equals 1.405. My solving steps are the same. That has not changed because my equation is still the same, right? So 105.375. When I add 550 to both sides, I get x equals 655.375. And my last is the middle. Okay, so in the middle percentage, remember if I'm doing the middle 20, okay, so here's this, I have to go 10% this way and 10% this way. So when I do that, I'm going to type in for this first one, 0.4. So when I type in 0.4, oops, I get, okay, so my formula is going to be, actually let's do it this way. My z-scores, because I have 2, is going to be, or are going to be the negative version of this and the positive version of this. So I'm solving this equation twice. 550 divided by 75 equals negative, and x minus 550 over 75 equals positive. In both cases, once you do this math, and I'm going to kind of skip the steps for you this time. Once you do this math, I got for the first one, the range would be 531.025 to 568.975. So this is definitely a quick overview of inverse. And if you have any direct questions, you can always contact me with questions.